Hello everybody, welcome to today's lesson where we try to do synthetic division to find complex zeros. So for example number 1, we are going to be taking x to the third minus 6x squared plus 13x minus 10, and we are given the factor x minus 2, and we're asked to find the other complex zeros. But before we can do that, let's review real quick what a complex number is. Complex number is a number that has some number plus or minus bi. And how do we get the imaginary number? And this is hopefully review, but if not, that's why we're talking about it now. It's because when we have the square roots of a negative, like this is when complex numbers come into play. The square root of -1. Go ahead and try that into the calculator, and you'll notice that it says error because you can't take the square roots of a negative. You cannot take the square roots of a negative. So that is when complex numbers come into play, because, or imaginary numbers, the square root of -1 is equal to I. So that's how we start getting into complex numbers. So for another example, if I gave you the square root of -4, think about it this way. We're going to take out that negative, and I'm going to bring out the I on the outside. So now I got the square root of 4. And then what's the square root of 4? 2. So what's the complex number in this case? 2i. So kind of just remember that that's how we get complex numbers. Just one more for an example, just one more. So think about the square root of -9. What's the answer going to be? It's going to be positive 3i. Again, because the negative gives us the I, and the square root of 9 gives us the 3. All right, so now that we reviewed kind of how complex numbers arise, let's go ahead and try this example. So we are trying to break down this polynomial, so I'm going to go ahead and do synthetic division. This is x minus 2, so it's a positive 2. We have a 1, -6, 13, and -10. And we're going to do synthetic division to solve. Bring down the 1. 1 times 2 is 2. Add -4, -8, add, that's 5, 10, and our remainder is 0. Remember that the remainder is always supposed to be 0. And so we have that our factor f of x is equal to x minus 2, and then I'm going to write this one right here. I'm going to write it x squared minus 4x plus 5, like that. So now that we broke down this polynomial into this step, we can find the 0 of this one by saying x minus 2 equals 0 plus 2 plus 2. X equals 2 is one of the zeros. Don't forget about that one. A lot of students tend to forget about that one. And then here, we're going to try to factor this. We're going to try to factor it. Two numbers that multiply to a positive 5 and add to a -4. There is no way that's possible. So we're going to have to use the quadratic formula. So we're going to use this. We're going to say x squared minus 4x plus 5 equals 0. And to solve, we'll use the quadratic formula. Hopefully we know the quadratic formula by now. And it's x equals the opposite of b plus or minus b squared plus 4 times a times c. That's how we do the quadratic formula, all divided by 2a. And we have to identify what my a is. My a is 1. My b is -4. And my c is positive 5. All right, so that's where I got my letters from, so I'm going to plug them in. I got a -4 here. I have a -4 here. I have a positive 1 and a positive 5. And then a positive 1. I plugged in all my A's, B's, and C's. And now we got to simplify. A negative and a negative is a positive. plus or minus a negative 4 squared. Remember, it's the entire negative 4. A negative times a negative is a positive. And then we have 4 plus times 1 times 5, and that's not supposed to be a plus, that's supposed to be a minus. I apologize for that. That is supposed to be a minus. There we go. So we got minus 4 times 1 times 5 is 20, like that. All divided over 2 times 1, which is 2. So we've simplified the radical. Let's continue simplifying it, and let's look at what happens in this situation. We have 4 plus or minus the square root of 16 minus 20 is going to give us that negative 4 under the square root, divided by 2. Notice that this is where my complex number comes into play. Complex solution, because of the negative under the square root. All right, so now we're going to simplify that. Again, we're going to refer back to these examples up here. So let's simplify that. So we have 4 plus or minus. Again, the negative comes out as I, and then the square root of 4 is 2. So that is 2i divided by 2. And then if we recall from the previous lesson, we can write that in the following way. We can say 4 divided by 2 plus or minus 2i divided by 2. And if I go to rewrite that, 4 divided by 2 is 2 plus or minus. And then we got 2 over 2, which is technically just 1 over 1, so that's just 1i. So our answer to clear it up would be 2 plus or minus I. And remember, that's 2 different solutions right there. Don't forget, we have 2 plus I, and then we have 2 minus I, but people tend to write it together, just so you know. Just do know that those are 2 different ones. And then what's our third solution? What's our third solution? Our third solution is 2, from the factor that they gave us at the beginning up here. Our third solution is 2 from the factor they gave us. So x equals 2 plus or minus I, 2 minus I. But remember, these two tend to be written like this. So if you were to try to type this into Delta Math, it would be x equals 2, and then x equals 2 plus or minus I. And if we remember the fundamental theorem of algebra, this is x to the third. So if the degree is 3, the number of roots is 3. And did we get 3 roots? That's what the fundamental theorem of algebra tells us. Yes, we got 2 plus or minus I, and 2 minus I. So we know that we have 1 real and 2 complex. And the complex always come in pairs. Remember, we also learned that. Always comes in pairs. A negative and a positive. Alright guys, that's it for this example. Join me in the next video for another example. Have a good day.